All right, in this last video for this section, I just want to show you some other ways that we can get sequences. So the Fibonacci sequence is a famous sequence. It shows up in all sorts of cases in nature, like the spirals in a sunflower center. I've put some links in Canvas to some interesting things about Fibonacci sequences. But let's look at what the sequence is. So this is a recursively defined sequence. So it's defined based on previous terms. And in this case, we're going to start with F0 is 1 and F1 is 1. So the first two terms are going to be 1. And then every term after that is gotten by taking the previous terms and adding them together. So Fn is Fn minus 1 plus Fn minus 2. Okay, so all that's saying is here to get 2, I looked at 1 and 1 and added those together. To get 3, I look at the two previous terms here. I have 1 plus 2, and that gave me 3. The 5 came from 2 plus 3, and so on. If I wanted the next term, I would take 89 plus 144. Which is 233, and so on. Okay, so that's the Fibonacci sequence. I just wanted you to see that one. Here's another way to get sequences. These ones come from figures. That's why they're called figurate numbers. And they represent the number of dots necessary to create these figures. So we can talk about triangular numbers. Those are the number of dots necessary to make these successively larger triangles here on the top of your screen. And underneath you've got square numbers where we're making squares. Notice that these numbers also have a pattern. This is 1 squared, this is 2 squared, 3 squared, 4 squared, and so on. We can use differences to help find patterns. And then assuming that the pattern that we discover continues, we can find later terms in the sequence. So here, the sequence I'm given is 5, 6, 14, 29, 51, 80. Staring at that sequence, it's hard to see a pattern, right? I'm not adding the same constant each time or multiplying by the same constant. And so one thing that we can try is going back and looking at the differences and seeing if we can find a pattern there. So what I'm going to do is subtract successive terms. So 6 minus 5 is 1. That's where this 1 came from. 14 minus 6 gives me 8. 29 minus 14 gives me 15, and so on. So I'm subtracting successive terms to get these. This is called the first difference. And I could do that again. And if I do that again, you can see that the difference of each of those is found by is found to be the same, right? The difference of each of these is 7. 8 minus 1 is 7. 15 minus 8 is 7, and so on. This first difference is an arithmetic sequence. It's an arithmetic sequence with common difference 7. So if this pattern continues, and I shouldn't have written right there, I'm going to erase a little bit. If this pattern continues, we would expect the difference here to be 7. And so the number that goes here must be 29 plus 7, which is 36. And so to find the number that goes here, we notice that we get the next number by adding this way, right? 5 plus 1 equals 6. 6 plus 8 equals 14, and so on. So the number that goes here is going to be 80 plus 36, which is 116. So the 7th term in our sequence is 116.